Is your software product secure? It's a simple question, but it could be very hard to answer. If your customer is asking that question, you can tell him no. But you can't really and honestly say yes either. It is not really an option to tell your customer it is a bad question or it depends. So as an organization, you're most likely to go with a yes answer. Hey, you might even think about that ISO 27001 certificate that you have lying around. Isn't that proof that your product is actually secure? Well, absolutely and totally no. It is proof that you have passed a compliance certification, which seems to be a very bad proxy nowadays for actual security. Real product security starts with the understanding of risk. No risk means you don't need security. Once you have defined that risk, you can start solving the problem in a structured way. And that is where frameworks and maturity models come in as a systematic approach to manage and mitigate that risk. In this episode of AppSec Science, I will focus on what frameworks are, how can they serve us, rather than being a massive nuisance. I'm really excited about this episode as I will try to put the pieces of a puzzle together that I was struggling with myself a couple of years back. So, strap in and let's dive into it. Hi, my name is Aram, and I've spent most of my career in application security, first as a researcher at the University of Leuven in Belgium, then as an industry expert, and lately as a core contributing member to the OWASP SAMM project. And in this video series, I would like to share some of my insights with you guys. This episode focuses on somewhat less typical for me and perhaps even boring topic: ISO 27001 framework, NIST cybersecurity framework, CIS critical security controls framework. All of these things called frameworks, aren't they just relevant for the GRC teams of very large organizations? Hey, we already have an awesome tooling in place and all our dashboards are green. Why on earth should we worry about frameworks? And even if you are convinced of the power and the added value of frameworks, there are so many frameworks to pick from. Why is that, and which one shall you pick? But before we zoom into those questions, let us briefly dissect a couple of more fundamental concepts in the domain of security. Let's start with defining what is security, and I promise I'm going to be brief. Security is defined as confidentiality, integrity, and availability. Make sure that unauthorized actors cannot access or even know about your assets, they cannot modify those assets, and assets are available whenever you need them. That's it. Simple, right? Unfortunately, despite this simple definition, the domain is broad and deep. At the broadest level, we talk about information security. Information security is focused on protecting information. And information that is stored in systems, transmitted via networks, processed by servers, handled by people, stored and transported physically. So any assets are in scope here when it comes to guaranteeing these three properties: confidentiality, integrity, and availability. Now, there are many ways you could dissect this broad domain of information security. I like to view this domain as physical and cyber. So within information security, we have cybersecurity that deals with protecting all our digital assets. These assets can be data and information, applications and services, infrastructure and platforms. In other words, anything that lives in or depends on information technology. Now, if we zoom further into the cybersecurity scope, one of the key buckets here is applications. This includes both the applications that you buy as well as the applications that you develop. Your CRM system, your accounting software, cloud platforms, all of these are applications that you would typically buy from other vendors and use it as a SaaS or run on-prem. Application security in this context is about making sure that you configure and manage them properly. Then there are applications that you actually develop, whether this is with an in-house team or an outsourced team. You might use these applications internally, sell as SaaS, or as a physical product with digital elements, mobile applications, and so on and so forth. Application security focuses on your general organizational strategy, policies, processes, standards, training programs to make sure that the applications you create have security baked into them. And then in this context, the biggest component of application security is actually the software development lifecycle, or SDLC. SDLC is a structured process to design, build, test, deploy, and maintain high-quality software, preferably at optimal cost and fast time to market. So in other words, as cheap as possible, as fast as possible, at an acceptable, hopefully very high level of quality. And guess what? Security is one of those qualities. In addition to SDLC, there is this thing that people often refer to as secure SDLC or SSDLC. I'm not a big fan of that buzzword because a regular SDLC should already include quality, hence security. In any case, your development process must include security-related activities. Here are some examples to demonstrate the depth of this discipline and why bringing in tools and showing off your green dashboard is not nearly enough. Above all, you need to understand the threats and the risks to your business when developing an application. An internal application with no sensitive data is unlikely to be needing the same level of security as an externally facing healthcare application. Aside from the business risk, you need to consider the technical risks that could lead to an undesired event. For instance, a curious member of your team might be trying to figure out what's wrong with the Belgian Prime Minister who is registered in your healthcare application. The business and technical risks can help you create the right security expectations and specifications. Once that is in place, our architects have to make sure they use security design principles, think of least privilege, defense in depth, zero trust, and so on. Then coding comes in. You need to write code securely. If you have some technical background, think of parameterizing queries, using the right output encoding architectures, and so on and so forth. Once the code is in place, we need to make sure the code is built and deployed securely. Many other activities are also taking place during and post-development, such as making sure that all those security requirements are correctly implemented. And then the more traditional activities come in, like scanning your code with all sorts of tools, making sure your dashboards are green, pen testing, fuzzing, stress testing, and the list goes on and on. Now, the taxonomy I have shared with you is a model. And there is this saying that says all models are wrong, but some are useful. This taxonomy is a simplified view of the world of security and clearly cannot capture the full complexities of the real world. So think of this as a mental tool to help you understand and reason about the domain of security. So far, we have covered what security is and how broad and deep it goes. But aside from being very extensive, there are more complicating factors that make security such a challenge to deal with. Security is intangible. It is extremely hard to see, measure, and perceive. The only exception is perhaps physical security. Protecting bank vaults, data centers from physical invasion is something that we have been doing for quite some time. I don't think threat actors trying to break into your data center physically is on the top of your security risks. In cybersecurity, we can see the problem only when it's too late, or there has been a breach. Some breaches are even seen quite some time after they happen. As opposed to a bank vault, it might be very hard to figure out that your data was stolen because you still have the originals. It's not like it's missing, unless it's a ransomware attack. Most organizations nowadays also have many integrations. Imagine companies like, I don't know, FedEx or DHL. These companies seem to be doing a single thing. They're just doing shipping, but they have hundreds of dependencies and integrations, both internally and externally. And every integration expands this thing we call attack surface. Cybersecurity is also asymmetric in the sense that it is very easy to introduce a tiny mistake, but it is super hard to find every mistake. The attacker needs to be right just once. In addition to the integrations, the applications themselves are one of the most common attack vectors. Modern applications are living ecosystems of services, containers, cloud resources, and many more concepts. We adopt new technologies like 5G and AI before we even fully understand the risks. And every application development process works under constant pressure from competing priorities of speed, cost, and quality. And as I've already mentioned, quality is the one that loses this game. And security is one type of quality. So security is broad and there are so many potential issues to deal with. How do we solve that? Unfortunately, there are no quick fixes for security. We can't solve it with shortcuts. We can't solve it with a tool. We can't solve it with awareness trainings. We can't solve it with a pen test. Neither regular patching is going to help us. We need a holistic and continuous approach. And luckily, the security community actually knows how to solve all of that. Security frameworks offer exactly that systematic approach that focuses on getting the right people with clear responsibilities, knowledge what to do, tools to help them streamline their tasks, and above all, understanding of risk. So, frameworks are the only possible and meaningful solution to systematically manage the security challenges. But what is a framework? Why do we have so many frameworks, and which one shall we pick as an organization? A framework is like a playbook of a football team. And it doesn't really matter whether you're now thinking of American football or soccer. A playbook is focused on different players with clearly defined roles and actions. A single superstar can rarely win the game if the rest of the team is not doing what they're supposed to be doing. Also, a single strategy or drill or tactic is not going to win all games. Every game requires a different strategy and preparation. The reality of cybersecurity and frameworks isn't much different from that football team's playbook analogy. A framework offers a structured collection of best practices. It is a catalog of solution patterns that focuses on people, processes, tools, or could even offer security features out of the box. And just as with a football team, it is not the case that you can use one solution or one pattern to help you with any possible strategy. You are going to need the full framework, the full catalog, to figure out which ones that you need given your context, which is risk. So clearly, we need frameworks to manage security. But the question is, why do we have so many frameworks, and can't we just pick one to win them all? Unfortunately, that is very, very hard to do. And here are some key reasons why. A framework is essentially a model to describe the world. Models are always sort of academic and create some assumptions of the real world, and the real world is really, really messy. So all models are by definition wrong, but some of them may be useful. So many frameworks pick a specific point of view, abstraction level, and scope. To illustrate that better, let's go back to the security scopes again. As we've presented them earlier, we have the broadest scope of information security that contains two largely non-overlapping subdomains of physical security and cybersecurity. Cybersecurity is about protecting all digital assets. Application security largely focuses on applications you develop as an organization, but it also contains everything that is developed under a shared responsibility model. Finally, a substantial portion of application security is about your software development lifecycle, or SDLC. Now, it seems that when it comes to frameworks, the broader the scope, the shallower the depth. So for instance, ISO 27001 and NIST CSF 2.0 cover a relatively broad scope, but creating a secure organization based on these frameworks alone would be very hard, especially for someone who is new to the discipline and cannot easily translate from very high abstraction level to a concrete solution. Now, these frameworks do sometimes reference another framework for more details and more information and more specific type of solutions. For instance, ISO 27001 framework comes with a family of frameworks such as ISO 27002, 27005, and so on, which provide more details, concrete answers that are outlined in a more abstract solution, which is presented at the higher level. NIST CSF 2.0 comes with a mapping to NIST 853, family of catalogs, and references also to NIST SSDF for the SDLC. Typically, frameworks specify either the what, in other words, which best practices shall we have in place. For instance, make sure that you implement secure authentication technologies. Other frameworks focus on how to do that. For instance, use strong passwords and multi-step verification for user authentication. The last topic I would like to address is a taxonomy of frameworks. You have probably heard of maturity models, control frameworks, management frameworks, program frameworks. There is no real official taxonomy, so it is largely my own creation, my own interpretation. I like to think of frameworks in three categories. Management framework set the goals and expectations. These typically stay at a higher level of abstraction, and they tell you often what you have to do, but not really how to do it. For instance, ISO 27001 and NIST CSF fall into these category of frameworks. Control frameworks describe the concrete practices and solutions. These are focused on telling you the how. Often, management frameworks come with a mapping to control framework. For instance, like I've already mentioned, ISO 27001 comes with a mapping to ISO 27002. NIST CSF comes with a mapping to NIST 853. Note that controls can be abstract and very specific. So the fact that a control tells you how to implement a specific best practice does not necessarily give you all the information that you need. For instance, using HTTPS A+ certificate is a very specific control, although you can go even further where you specify the exact cipher key and algorithm. Make sure you have secure communication is a more abstract version of that. Then, maturity frameworks show you the growth path from 0 to hero, because none of this can be achieved instantly or linearly. Finally, compliance frameworks allow us to get certified and demonstrate compliance. The ISO family is an example from this category. And of course, real life is messy and many frameworks blend these categories. OWASP SAMM is a great example. It gives you strategy, controls, and improvement guidance all in once. It is also a maturity framework. ISO is another example of a blend where the framework essentially covers management, control, and compliance. It doesn't really tackle maturity, although you are free to use something like CMMI in combination with ISO 27001, as for instance you can do in the SAMMI tool. Unfortunately, and this is my personal opinion, the compliance approach rarely ends up in more security. As the Goodhart's law goes, once a metric becomes the goal, it ceases to be a good metric. In other words, security is our goal, and if compliance becomes your goal, it ceases to be a good metric for security. In our sports analogy, it's like preparing your football players to look very muscular, lean, and aggressive, and then scoring these players based on that, and that would be your metric. Clearly, it is the game result that counts, not how prepared your football players look like. Compliance prepares us for the auditor and not the real attackers. And as I've mentioned earlier, it is easy to make a simple mistake, but it is very hard to find all mistakes. So far, I have talked about how broad and deep the domain of application security, cybersecurity runs. I hope I have convinced you that if you want to get the job done well, you do need to start looking at frameworks. But then the key question is, which framework shall we pick? And unfortunately, at this point, I have to give you the "it depends" answer. One thing is certain, it is unlikely that a single framework is going to get everything covered. Here are my top picks for frameworks in the context of any organization, large or small. We are, in fact, using all of these frameworks in the context of my own organization. Physical security is largely irrelevant for us, so I'm going to skip this part. In the domain of cybersecurity, I would definitely go with the NIST CSF framework in its latest version 2.0. Unfortunately, CSF does not cover much on application security. It does reference the NIST SSDF Secure Software Development Framework, but SSDF has a much better alternative. For application security, in fact, there are two complementary frameworks that I would recommend. OWASP SAMM is an excellent application security framework, and clearly I am somewhat partial to this story. SAMM allows you to measure where you are, which is amazing. I haven't seen many frameworks offering that measurability aspect. And then knowing where you are and what your weaknesses are, you can start planning and improving from there. You can even demonstrate your improvements because of this measurability aspect. If you're looking to pick just one framework across the whole spectrum of security, SAMM is the framework I would go with. However, SAMM could have a somewhat steep learning curve. It could be hard to interpret, especially for your DevOps teams. To solve that, there is a complementary framework in the OWASP community called DevSecOps Maturity Model, or DSOM. DSOM is a much more practical and easy to understand, especially for your tech teams. The two frameworks have mappings, and you can leverage those to make sure that you don't have to implement the same thing in two frameworks, so you can easily jump from one framework to another. Finally, you can even go a step further and look into the OWASP Application Security Verification Standard. That is an excellent security requirements framework. This framework you can use in combination with any security framework because it sits much closer to the technology, albeit ASVS is specifically targeted for web application development. All right, let's wrap up this episode with some key takeaways. Cybersecurity and application security are very broad and they also run deep. They come with various challenges and frameworks serve as a systematic approach to tackle these challenges. A framework is essentially a structured set of best practices to manage and mitigate security risks. Frameworks can also provide a management methodology that allows you to assess your current security posture and plan and implement improvements across teams, business units, or the entire organization. There are many frameworks and each has its scope and limitations. A single framework to rule them all would be nice, but that would be very hard to create and maintain. Application security and software development lifecycle are the hardest domains to master. The best framework to start with is OWASP SAMM, although I know I am a bit biased. SAMM sits in the ideal spot where it heavily focuses at the hardest domain in security, but it also provides quite some bridges towards other scopes and domains. Finally, security by compliance doesn't work. You cannot hope to outsource your security to the GRC team and hope that they can solve the challenges. However, getting compliance by investing in real security does. Our organization has got an ISO 27000 certification with nearly zero effort. Well, we had help from our SAMMY tool to generate some documentation to convince auditors, but in essence, we had all best practices already implemented for the sake of actual security, taking into account our risk. I hope you have enjoyed this episode of AppSec Science. Thank you for watching. Ciao.